Nick Maxwell, I took a course when I was an undergraduate, it's quite a long time ago, it's 35 years or so ago, called Aims, Methods and Values of Science and Technology, or was it just of Science?
Well, I'm delighted that you remember the name of the course, because I'd forgotten it.
It was, I found it fascinating and also astonishing, really, because it was very critical of the way not just science was done, but really the whole setup of the academic venture, particularly, obviously, as it applies to universities, and was very struck by it, and also by the range of reading that was done even before the course started. I think Zen and the Art of Motorcycle Maintenance was one of the books. I can't remember the full title. The subtitle was Limits to Medicine. There's Ivan Illich, pretty sure was on that list as well, along with The Structure of Scientific Revolutions, Thomas Kuhn. So a great deal of breadth and a very, what do you say, deep insight, or a very comprehensive insight into the way that all kinds of academic ventures are conducted, and one that was not only thought-provoking, but I found personally very convincing. So I'm very, I think we're very privileged that Nick has agreed to do an interview. The relevant aspect of Nick's work, I think, for the ecology course is along the lines of how, from my perspective, how did we get into this mess, and from something more germane to what Nick's general argument is how do we get out of it? But I think it's probably a good idea to just ask Nick to explain what his thesis is in his words, because I don't think has deviated from what he's been teaching in all of that time, but actually his arguments have luckily become better known, and he's spent a lot of time carefully articulating them since. But perhaps you could explain your words.
Yeah. Well, it all goes back to a summer vacation in 1961, I suppose it was, when I was doing philosophy at Manchester. I'd just done the first year of the undergraduate course, and I was struggling with philosophical problems, and I was sort of tangled up thinking about these things, and miserable. And then I had this, and then I started to write. I'd always wanted to be a novelist, and I'm a failed physicist and a failed novelist. And I started to write a short story, but I also started to write about my thoughts and feelings and things. And I had this sort of explosion, and it occurred to me, two big things occurred to me. First of all, three things. First of all, Cartesian dualism is wrong. What is within us is just as much a mystery as what is without us, and we're a kind of interplay between what's within and what's without. That was my great revelation. And furthermore, that philosophy should be about how to live. And the problem with most professors of philosophy, they already decided how to live. They were professors of philosophy, and they didn't really have a problem about how to live. And so they weren't engaged in the real substance of what philosophy should be about. And I was going to go back to Manchester and tell all these professional philosophers that this is what philosophy should be about. And I remember writing down in this diary I was keeping, the riddle of the universe is the riddle of our desires. And in a way, all my work has been amplifying that sentence that I wrote down about the fundamental importance of improving our problematic aims as we live, as we engage in what we're doing. So I went back to finish my course, encountered Oxford philosophy, which I thought was ghastly. And then I decided to write an MA thesis on my ideas, if I could sort of work out what they were exactly. and then get the hell out of this madhouse of academia, as I then saw it. And then I discovered Karl Popper, and I was immensely impressed. Popper I'd sort of half been thinking along lines somewhat similar to Popper's, but he had really sort of spelled it all out in a very rigorous way. And there was one passage that especially impressed me, and that was where he said, justice, the idea of justice can survive a bad judge and a bad judgments, but it can't survive the decay of the idea that there is such a thing as truth, the idea of the facts of the matter. And I had been sort of tempted with thinking that the way to sort out the problem of how you fit together the physical universe and the world as we experience it was to think of these as two stories, and you shouldn't take one story any too seriously. And then it dawned on me, no, that can't be right. I've got to take this point that Popper makes, which is really a moral point for realism, seriously. And I went and I was an occasional student at the LSE and used to go along to Popper's seminars, which were dramatic and terrifying because Popper was very fierce, reduced people to tears with his fierce criticisms, but also enormously impressed. And then I came down to UCL and got this job, and then it began to occur to me that perhaps, after all, Popper hadn't quite managed to solve the problem that he claimed to solve. There is this big problem about science. How can you verify theories in science? It's called the problem of induction. Because a theory makes predictions about phenomena everywhere, but we can only verify a theory for a finite number of its predictions. So we're always infinitely far away from verifying a theory. So how on earth can we verify theories? But we do seem to. People have been struggling with this problem ever since David Hume introduced us to it a century or two ago. Popper had the idea, well, we should take Hume seriously. We can't verify theories, but we can falsify them experimentally. And that makes scientific progress possible because we can learn that we're wrong, and therefore we have to think of something better. And that's how science makes progress, through a process of conjecture and refutation. But it then dawned on me that this doesn't actually work, because if you look at physics, given that we accept a theory, a unified theory, that is a theory that says that the same laws apply to all the phenomena that the theory applies to, there are always going to be endlessly many rival theories that will fit the evidence just as well, but which are disunified. They're sort of patchwork quilt theories that are specially concocted to fit the phenomena even better and make predictions about phenomena we haven't yet observed, for example, in the future, or phenomena we haven't observed, that just arbitrarily make different predictions. We simply ignore these theories. So there are all these possibilities that can be concocted to be even more successful empirically than the theory we accept, and we just ignore them.
Yes.
So in my view, that meant that there is this big assumption built into the whole enterprise of physics, namely that there is some kind of underlying unity in nature, that the universe is such that all seriously disunified theories are false, whatever their empirical success may be. And science can't really proceed without this assumption. But how do we know that the universe is like that? Well, we don't. It seems to work, so at least it's worked so far. It seems to have worked reasonably well so far. But we don't know. And it's quite likely to be false, or the version of it, the more precise version of it that physics takes seriously at any given stage, is very likely to be false. If you look at the history of physics, you see we've changed our ideas a number of times about the sort of way the universe might be unified or physically comprehensible. So we need to try to improve this assumption as we proceed. And then I've invented a sort of framework in which one can do this, that you formulate the assumption in the form of a hierarchy of assumptions. And as you go up the hierarchy, the assumptions get less and less substantial and more such that they more or less have to be true for science to be possible at all, or the pursuit of knowledge to be possible at all. And so more likely to be true. And so at the top, we have the assumption the universe is such that we can acquire some knowledge of our local circumstances, such as to make life possible. After all, science is an attempt. It's various things. But one of the things it's trying to do is to discover what kind of universe this is.
Yes.
And you could put the point like this, that we can't really do this without some sort of preliminary idea about, in general terms, about what kind of universe we're in. I mean, and think of it in very crude terms. If the universe was made up of gods, and it was gods who determined how things behave and what goes on in the natural world, our whole science and technology would be very different from the way it is today, because we would be doing what most people in history and prehistory have done, namely try to appease the god and please them and get them to do the things that we would like them to do and not do the things we don't want them to do. We would proceed in a very different sort of way. And if, on the other hand, the world is made of gods, gods are in charge, and we treat them as if there's just an impersonal, unified pattern of laws, they may start to get rather pissed off with us for not doing the things that we should be doing to please them.
It might be that the best unifying principle would be the most optimistic one. That actually we can understand the things that are of greatest importance to us.
Well, I think science is a sort of mixture of optimism and pessimism.
Yes.
I think that you have to be, in order, scientists that achieve something have this kind of tremendous optimism about what's possible. But you also have to combine that with enormous skepticism about whether you have actually achieved it. So you have to have this crucial mixture of optimism about hope about what it may be possible to achieve, and skepticism about what you have actually achieved, so that you subject your conjectures to severe criticism. And I think that part of Popper is absolutely right, that you need both those things together.
But the underlying assumptions are terribly important, the sort of worldview, if you like.
Well, that's what seems to me the implication of this argument, that science isn't possible without... science has to make some sort of assumption about what kind of universe we're in order to cut down on the possibilities to consider, the possible theories to consider. That's kind of inevitable. And if you look at theoretical physics, which is sort of, in a way, the fundamental natural science, then the only kind of theories that physicists take seriously are unified theories. So there are these two requirements. It has to be sufficiently empirically successful to be accepted, and it has to be sufficiently unified. And in the end, what that means is that there is implicitly, in my view, there is implicitly in theoretical physics this assumption that there is some kind of underlying unity in the whole universe, in everything that goes on. So there is a theory of everything to be discovered, and when we discover it, we will discover that it is a unified theory. That is, it says that the same basic laws apply to all phenomena, whether it's us or the sun or the center of the earth or empty space, whatever. It's essentially the same dynamic laws are governing how events evolve in time and space. And I then, so this is a kind of revision of Popper, because it doesn't dispute his claim that all our knowledge is conjectural in character, and it doesn't dispute the importance of falsification, although I think also verification is important as well. So that bit changed. But what changes most dramatically is there is a change in the basic intellectual aim of science from truth for Popper, to what one might call explanatory truth presupposed to be explanatory, a deeply problematic aim, and we have to have a conception of scientific method which is such that we're improving our aims and methods as we proceed. So there's a kind of interplay between our improving knowledge and understanding of what kind of universe we're in, and the methods of science.
It's a sort of iterative
and I think that helps to explain the enormous progressive success of science, that science has in practice put something like this into practice, but unfortunately the scientific community still believes in what I call standard empiricism, the view that in the end it's evidence that decides, okay, maybe considerations of unity are important as well, but in science you mustn't make any big assumption about the nature of the universe that is upheld as a part of knowledge independent of empirical considerations. In the end, it comes down to evidence. And that does seem to be a sort of deeply entrenched dogma in the scientific world, the scientific community. And when I got this far, I then realized that in a way one can develop the argument further, because it isn't just that there are metaphysical assumptions built into science, into the aims of science, but there are also value assumptions, because we want to try and acquire knowledge that is of value in one way or another, either inherently interesting or significant, because it helps us to understand and helps us to appreciate things we're interested in, or is of use. It can be used for all sorts of other ends. And then there is a kind of political dimension to science, or a social or a humanitarian assumptions built into the aims of science, in that science, the aim of science is that its products will be used, hopefully by people, hopefully to help enhance the quality of human life, although it doesn't always work out like that. So these two assumptions of values and social or humanitarian or political assumptions built into the aims of science are, if anything, even more problematic than metaphysical assumption. And so here too we really need to change our whole conceptions of science. So instead of thinking of scientific debate and discussion going on crudely in two domains, namely evidence, experiment, and theory, we need to think of it in terms of three domains of discussions: evidence, theory, and aims. And aims is as important as the other two. And the really important thing about aims is that the discussion, vital to science itself, needs to be, it isn't just scientists who need to be discussing this, but non-scientists need to be contributing to the discussion, because if it's questions about values and questions about the use of science, then the scientific community can't be in a position to decide for the rest of us, what are the values that are important, whose suffering matters most, what are the issues, what are the problems, the human problems that we'd be trying to help solve. So we really need a very different sort of relationship between science and the rest of the human world, in our whole conception of science, that non-scientists need to contribute to science in this sort of at present somewhat repressed domain of discussion, namely aims. That for me is one of the enormous, one of the virtue, one of the value of making discussion of aims explicit, that there would be more attention to what the priorities of scientific research are, and whether they're one of the problems with modern science is that it's very expensive, and so naturally who pays for science tends to set the agenda, and then of course also scientists are going to set the agenda and pursue the kind of research they're interested in, and so it may be that those whose needs are greatest, the poor of the population of the earth, their interests will tend to get somewhat overlooked. And so that's the kind of issue that needs to be looked at and corrected for, to make sure that the priorities of research reflect the most urgent interests of humanity.